Did you know that for every 1 million antimatter particles back in the Big Bang, the birth of the universe, there was actually not 1 million, 1 billion antimatter particles. There's actually 1 billion and 1 matter particles. So what that basically means is that if there's a big war going on between them, normal matter won by 1 particle. But surprisingly, antimatter still actually exists to this day. And actually, there's even such a thing as anti-hydrogen and anti-helium that's been discovered since the 70s. Fun fact, back in the early days, by early days, I mean the first second of the Big Bang, actually, it wasn't what you're thinking, there's gonna be one star and then an anti-star. That's not how it worked. Actually, it was just because what happens is that the standard model is comprised of quarks and leptons, and which are thereby formed by gluons, right? So in the start, what happened was the gluons that formed quarks and stuff. So those, right, were going up against the anti-quarks and the anti-leptons and stuff like that. We won, but nowadays, because in the most common hadrons, which is a proton and neutron, there are a bunch of others, but they're really rare and they die out really quickly. But protons and neutrons, right? Two up, 1 down proton, and then 2 down, 1 up neutron, because the up quark has a positive charge of 2/3, and the down quark has 1/3, which adds up to +1 and 0. And then you have the electron to cancel out all the protons, but you need the neutron so that stays stable in the core. You could also do that with antimatter, because there's also an anti-up quark, an anti-down quark, and it's actually not even called an anti-electron. It's actually called a positron. Fun fact. Also, speaking of which, there's also a variation of hydrogen called muonium, which is not muonium. Muonium. Yeah, the variation of hydrogen, which if you can't tell, a muon is I'm pretty sure it's 200 times bigger than an electron. And so muonium is where the hydrogen atom, instead of having a hydrogen and one proton, 1 neutron, and an electron, or you don't even need the neutron. Now it's 1 proton, 1 neutron, and a muonium particle. Instead of a electron field, it's actually a muon field.